This is Salt Lake City, one of the fastest growing cities in the United States, and host for the 2002 Winter Olympic Games. While the eyes of the world look toward Salt Lake in 2002, the city is rolling out a $1.6 billion red carpet, a complete reconstruction of 17 miles of Interstate 15, the city's main north-south freeway. The project is unique because the Utah Department of Transportation has mandated that it be finished in only 4.5 years, half the normal time for a project of this magnitude. To meet this aggressive schedule, design engineers included in their plan the use of geofoam, expanded polystyrene blocks, in place of traditional fill material, the largest use of geofoam ever on a single project. Interstate 15 is a major north-south corridor linking NAFTA partners Canada, the U.S., and Mexico. As a vital lifeline to the nation and typical of much of the nation's interstate system, age and increasing traffic have taken their toll.
Originally, I-15 was built in the 60s, and it was designed to have about a 25-year life. So we're well into the 90s now. It's surpassed its useful life, and so it really was a matter of it needed to be done. The Department of Transportation was very forward-thinking in deciding that when it was redone, to widen it completely, to make it the most modern, up-to-date facility as possible, rather than just doing a little improvement here or a little improvement there.
This I-15 geofoam project is bigger than life. It's the biggest geofoam application in the United States and one of the biggest in the world.
Geofoam offers a ready solution to two perpetual highway construction problems: time constraints and soft soil settlement. It's been used in a variety of geotechnical applications for more than 25 years. Expanded polystyrene geofoam blocks begin as a resin that contains a hydrocarbon blowing agent. Exposing the resin to steam softens the polymer, allowing the blowing agent to expand, creating a pre-puff, 40 times the size of the resin bead. The pre-puff is conditioned and poured into a mold, and under heat and pressure, the beads further expand and fuse to form a molded block of super lightweight material, a perfect substitute for soil in roadway construction. Geofoam is approximately 100 times lighter than soil. It simply takes up space without adding weight to the ground beneath it. During the harried first months that contractors put their proposal together, they proposed more traditional foundation materials and treatments. Geofoam was merely a footnote in the engineering strategy. It quickly became clear, however, that the preliminary foundation strategy would run into several problems, and a task force was formed to study the potential use of geofoam.
And I think originally they probably heard the idea of using foam as fill material probably sounded pretty crazy to them. But as they continued to look into it and they saw that it was a fairly simple concept, that of just taking up space without adding weight, they started seeing the advantages of it right away.
One of the advantages of using geofoam was the amount of time saved building embankments on the soft soils found in the north portion of the interstate near the Great Salt Lake.
On the I-15 project, we're constructing a lot of the corridor on clays. Clays take time to consolidate and settle. When I-15 was originally built in the early 60s, some of these fills were allowed to settle up to 2 years before they placed pavement on them.
Another problem that required attention was the settlement of embankments on buried utility lines that ran perpendicular to the interstate.
We have several places along the corridor where there are storm drain lines, gas lines, water lines that run fairly close to the walls, and we realized that with normal construction we would cause excessive settlement and rupture these lines.
We were told by one of the engineers that had they relocated the utilities instead of using geofoam, the time period would have been around 1 year to relocate those utilities at a cost of about $1 million.
Geofoam placement begins with site excavation, leveling, and a uniform layer of sand. The blocks then are stacked in staggered layers to eliminate any voids. For smaller shapes and sizes, geofoam is easily cut on site with heated wires. The geofoam side slopes are covered with soil or lightweight aggregate. The final geofoam layers are topped with 6 inches of reinforced concrete load slab, 24 inches of traditional fill material, and finally the road surface, which consists of approximately 12 inches of asphalt pavement. Before construction crews finish the I-15 project, more than 1,000 diesel trucks will have delivered over 120,000 cubic meters of geofoam for use as lightweight fill material for the roadway and embankments.
This is a project that has brought a lot of attention to geofoam, a lot of exposure. It's going to help a great deal in promoting the further application of geofoam in a variety of applications across the country.
When completed, the Salt Lake City I-15 corridor will boast 6 lanes in each direction, 144 rebuilt bridges, and an advanced traffic management system including 130 closed-circuit television cameras, 520 traffic signals, and 48 variable message signs. The new interstate will be in service well into the 21st century and create much interest in the use of geofoam throughout the transportation industry.